Morning.
All right, guys. We just completed another week of remote learning. It's crazy.
Yeah.
I have to say I'm really proud of you guys for being so consistent and just showing up every day and just getting caught up with things. Yeah, you guys are definitely a role model for everyone. So
Thank you.
I want to go over with you guys the enrichment problem that I posted 2 days ago, and the enrichment problem looked something like this. All right, it looks something like this, where you're asked to solve for all the angle measures inside of that triangle. So this problem is actually solvable in like 30 seconds flat. Okay, but you have to know a formula to do that. So I'm not going to use that formula just because you guys haven't been shown what that is yet. Okay, I want you to rely on the things that you already know thus far to be able to solve this, which everyone here has the ability. Okay, and it's not the most efficient way, but at the very least, I think it allows you guys to to think a little bit. Okay. Those who have started to think about this, okay, what are some of the strategies that you guys have come up with?
I mean, I used there was a enrichment problem that you posted a couple days ago that used like the quadratic formula, so I just used that.
So
I don't know if you can use that.
How so though?
I did because you said like 10 minus x multiplied by x will equal to the p squared. So I split the triangle at angle B. I split it not like in half, but I split it into two triangles like that. Yeah. So I got like that.
Good.
And then I put it into the quadratic like formula to get the two side lengths at the bottom.
I love that. Now the only thing is, okay, this setup here, is it a guarantee? Excuse me. Is it a guarantee that angle B is 90 degrees?
No.
It's not a guarantee, right? Because it's not a guarantee that angle B is 90 degrees, okay, then it's not. Oh, can you guys lower the volume just because I hear myself echoing? Then
Oh, perfect. I need to print something.
What was that?
Nothing.
Oh, okay. So because of that, then you cannot apply the concept of geometric means, okay, to this problem. And what I mean by this is, like the scenario where we had something like this, okay, where we have A and then we have B and then we have C, and if this was a right angle here and this was a right angle there, then then this formula is true, right? That A times B will equal to, what will it equal to?
C squared.
C squared. We cannot use that in this case, okay? Just because it's not the same setup, right? You see how this angle here is, it's not a guarantee that angle B is 90 degrees. Can everyone recognize that? Okay. So because of that, okay, I'm not going to use this route here. However, I am still, whoops, I did not mean to do that. And I can't bring it back now. Okay, so I'm just going to replot that. So I'm not going to go that route, okay, but instead, I'm going to do something a little different, okay? So I'm still going to call this A. I'm still going to call this guy right here, this entire thing here, B, and this angle there, C. And I'm going to introduce another variable. Because I drew that vertical line, I'm going to call that vertical line something. I'm going to call that vertical line Y, okay? And this is still going to be a right angle here because drawing lines at a right angle, we can still apply Pythagorean Theorem. What is the relationship between 10 minus x, y, and 8. Like if you were, is there an equation that we can maybe combine all three side lengths together that relates all three side lengths together? Is there a formula that does that? Yeah, Sawyer?
You could use the Pythagorean theorem. You could do 10 minus x squared plus y squared equals 8 squared.
That's right. All right, so looking at this right now, this equation is not particularly helpful because there are two unknowns here. And anytime you have two unknowns, like we don't have enough information to solve. Lucky for us, okay, there's actually, we have another piece of information over here, and that's this guy, y, x, and 4. How do they relate?
X squared plus y squared equals 4 squared.
Yeah. Okay, so now I'm in business, okay? Because I have two unknowns, but I have two unique relationships. I have two unique equations, okay? And that will be enough for me to solve. So math is very much a language, right? That follows a set of logic, okay? So what we're going to do now is we're going to like try to whittle away at figuring out what the unknowns are. So let's try to re-express those two equations, okay, that I just came up with. So what's the natural thing to do at this point? What would be a natural thing for us to do at this point with those two equations?
We could simplify 10 minus x squared, just so it's like easier to like combine the two equations.
Okay, when you say simplify, what do you want us to do exactly? Like what kind of operations do you want to take? Do you want me to go through?
Well, you'd like multiply, and then you get like 100 plus.
So you want me to FOIL?
Yeah.
Okay, so really quickly, because when you guys get promoted to Algebra 2 next year, right? You should get used to things that follow a particular structure, okay? And this was emphasized in Algebra 1, but I'm going to re-emphasize it here. Does anyone know what a minus b quantity squared like FOILs out to? This was, again, from Algebra 1. This was a squared, and then what happens now? What follows that?
A squared. A squared
Minus b squared.
Wait, no, it should be plus b squared, right? And then
Yeah, plus b squared. I don't know.
It's minus 2ab plus b squared. That's what it FOILs out to. So if I were to apply this structure here, right? If I were to apply that structure, 10 minus x when FOILed out, I'll get 100 minus 2 times 10 times x. That's 20x, isn't that right? Whoops.
yeah.
And then plus x squared. So that's how people who quote unquote are good at math are able to like really quickly FOIL in their heads. That's because they recognize this structure, okay? That template when FOILing, okay? It's all facade. It doesn't mean that they're smart or anything. It's just that they recognize that pattern, okay? So that FOILs out to that, and then what do I still have to add to this?
8 squared? Or no, plus y squared.
Plus y squared. That's right. And it equals to 8 squared, which is 64, right? And then the second equation here, nothing really changes because there's really nothing that I can do to that second equation, so nothing changes.
Well, 16.
Okay. Right, aside from the 4 squaring 4. So I have this. I have two equations, okay? And this is a systems of equations, okay, what can I do to possibly eliminate one of the unknowns?
Substitute.
I can certainly substitute, but the way that the two equations right now is set up, okay, it is primed for us to eliminate one of the unknowns by simply doing one operation. Does anyone recall? Again, this is like algebra 1.
Subtract.
We all, that's the only thing we got to do. We can subtract these two equations. And if we subtract these two equations, okay, 64 minus 16. Michael, do you have a calculator handy? What is that?
What is that? 64 minus 16? That's
Yeah.
48.
That is 48. Very good. That's 48. What's y squared minus y squared?
0.
That's 0. X squared minus x squared?
0.
0.
So I'm left with 100 minus 20x is equal to 48. Look at that. The work, everything's boiling down, okay? I'm going to subtract both sides by 100. I end up with negative 20x is equal to negative 52. Okay, divide both sides by 20. I end up with my answer as 52 over 20, or this is simply 2.6.
Can't you simplify it to 26 over 10?
Yeah.
Or
And then you just divide by 10 and you move the decimal over 1.
Yep.
32 divided by 13 over 5. So 13 over 5 is equal to 2.6.
That's right.
Oh, okay.
So it ends up being 2.6. Okay. So
Okay.
we're not done yet, but we found one of the unknowns. We've created other unknowns in this whole process, right? We created that unknown x, like it wasn't in the original problem. We created it. We found out what that is. We now need to move into other parts of this problem to find out what, the other unknowns that we've created, what those are. Any suggestions on what we can do to find out what the other unknowns are?
Could you just do 10 minus 2.6?
10 minus 2.6.
Because we find out what x is.
We found out what is, but by doing 10 minus 2.6, we'll just be figuring out what this side length over here is, right?
Yeah.
I mean, yes, you can do that. Sure, let's do that. 10 minus 2.
Right, but then, yeah, and then y squared, you already have two sides, so you could find the third one.
Right. So the point
And then
is, we need to get to that other unknown, right? So since we now know what that is, what x is, we can now go back to using this equation here that we wrote, right, to figure out what y is, right?
Right.
So we're going to say 2.6 quantity squared plus y squared is equal to 4 squared,
16.
or 16. Okay, and again, we're just going to go through and knock this out, right? So 2.6 squared.
6.
Michael, what is that? 6.76. Oh, actually, because I mentioned in the instructions there to not round until the very, very end, right? Let's hold off on doing that.
I didn't round.
Oh, you didn't round. It's just 6.76?
No.
Okay.
Yeah.
Okay. So plus y squared is equal to 16. And then we're going to subtract both sides by this.
What is it? 9.24.
I agree. Okay. And then we're going to now take the square root of that. Okay. And that's what y is. And again, we're going to hold off on rounding. I mean, like, let's not enter that into the calculator, because if we do, whatever answer we get, okay, that will end up being an approximation. So we're going to hold off on rounding, okay, for now. So that's the solution for y, and we have our answer for x. We're not 100% done yet. We still need to figure out what the original unknowns were for this problem, and the unknowns were the angles of the triangle, right? So how can I use the information now to figure out what A is? we've done all this work now, okay? How can I figure out what A is? I'm going to redraw the diagram with all the things that we figured out. So again, this is the situation right now, okay? Where we have, this is here is 2.6, okay? How can I figure out, oh, and this guy right here is 7.4, right? Because it's 10 minus 2.6. How can I figure out what A, B, or C is at this point?
You could sine
Okay.
it, sine or cosine or tangent.
We can use any of those trig functions, okay, that we've been studying for the past week to 2 weeks, okay? So by using, so Emmett, since you brought that up, right, can you give us a suggestion as to like how to find out what A is?
Well, for A, you can use 8 and 4 as the tangents, and then you can get A.
We actually cannot use 8 and
Wait.
4, and let me explain why. We cannot use 8 and 4 because
Oh, we don't have the 9-degree angle. We can use 8 and 9.2.
right. Can everyone follow what just happened? Right. Again, this angle over here is not 90. Okay. So therefore, the whole triangle, right? 4, 8, 10. That big triangle. You cannot use sine, cosine, and tangent for that because it's not a right triangle. However, we've sort of manipulated the situation so that this triangle over here, okay, is a right triangle. So we can use sine, cosine, and tangent there. All right. So Emma, try that again.
All right. So 8 and 9.24 square
So
root
square root of 9.24 divided by 8 will equal to what now?
will equal to A. Tangent of A.
Sine of A, actually.
Oh, wait. Oh, right. It's the hypotenuse. I was thinking of 8 and 4 still.
Okay. So sine of A, right? And then, Sawyer, what can we do to find out what A is?
We can use inverse sine. Morning, Mr. Chen.
Oh, hey, Ty. We can use inverse sine. That's right. So we can say A is equal to inverse sine of square root of 9.24 all over 8. Ty, can you do us a favor and figure out what that is?
Sure. Just give me a sec. All right, here's my calculator.
I got 22.3.
Okay, Ty, can you confirm that?
Yes. Hang on. 92.4 over. I did cosine. Whoops. Sine. 9.24 divided by 8. What were we supposed to round to?
We're trying to figure out what angle A is, so we need to use arc sine.
Yeah, I got that. But what do we have to round to the nearest tenth or hundredth?
Just give me maybe 3 decimal places.
All right, 22.331.
22.331.
Yep.
Sorry, do you have that?
Up to 22.332. Excuse me.
20,
Yeah, I have that. It's 22.332.
Okay. Okay. So we have angle A. Figure it out. Okay. I mean, right now, is angle B easier to solve or is angle C easier to solve?
Let's do angle C.
Yeah, I agree, Ty. So let's figure out what angle C is. Can you help us put that together?
Okay, so we have we have so no, it's not there. It's C.
Mhm.
So sine C
Okay.
equals I think it's 9.2 radical 9.2
Square root of 9.24.
Yeah. over 4.
Very nice. And then finally, C is equal to arc sine of square root of 9.24 all over 4. And then what do you guys have for me?
Okay, let's see. 4, and that's 49.458.
49.458?
Yeah.
Nice. And then what would be the easiest thing to do to find out what B is at this point?
Add the 2 and subtract from 180.
That's all you got to do. So we're going to say A plus B plus C is equal to 180. And since we know what A and C is, so 22.332 plus B plus 49.458 is equal to 180. Combine those two angles and then subtract from 180. Ty, can you tell us what that is?
Again, 40. Let's see. 49.458. 9.458 plus
That's 90.
22. It's 71.79.
71.79.
Not,
71.79, like that? Okay.
There's no thousands place.
Okay. So in the original problem, what did I say, Sawyer, to round to?
The nearest tenth.
To the nearest tenth. So now at this point, we're going to round to the nearest tenth. Okay. So our final answer, okay, for angle A is 22.3. Angle B.
Wait, angle B is wrong.
Oh, is it?
Yeah.
What is it? What is it?
Angle 92.
It doesn't add up to 180, all three angles.
yeah.
It adds up to 143.
So hi, you were supposed to take 71.79 and subtract from 180. So what is 180 minus 71.79?
Yes, what I was going to do.
Oh, okay. So what is that?
71.79.
It's 108.22.
Is that what you got, Ty?
Well, if we're rounding to the nearest tenth, it's 108.2.
Yep. So it's going to be 108.2, and then angle C is 20. It's 49.5. So there you have it. Again, this is not the most efficient way of solving this, okay? But at the very least, okay, you guys are able to solve for this like weird looking triangle that's not a right triangle. You know, when you guys move on to higher level math next year, okay, you will be able to solve the same problem, but way more efficiently, okay, with a new formula, okay. But at this point right now, I'm not going to give you that formula just because it's not in the curriculum yet. But you know, I'm really proud of you guys being able to go through all this using the information that you have thus far. Okay. Do you guys have any questions regarding this problem? This was definitely challenging. Go ahead.
How can we say this isn't a right triangle? Because the green one has a right triangle symbol in it.
So the starting, right? We started the problem off with this guy right here. Okay. Actually, we started off the problem by saying this. That this entire length was 10, right?
Yes.
Michael, side lengths 4, 8, and 10. Do we know whether or not that is a right triangle?
No.
How do we know?
4 squared plus 8 squared. That's only 80. Only adds up to 80.
That's right. 4 squared plus 8 squared, right? This adds up to 80 only, right?
Mm-hmm.
If this was indeed a right triangle, okay, this side length 10 right here should not be 10. It should be like square root of 80.
Mm-hmm.
Okay. So that's why this triangle is not a right triangle. And because it's not a right triangle, all those formulas, okay, regarding like sine, cosine, tangent, okay, they're not applicable for this problem. all the formula involving the geometric mean, that is not applicable for this problem, okay, because it's not a right triangle. So because of that, we had to like sort of work our way around, right, this tricky situation. And this is true for anything in life. Anytime that you don't know something, you try to turn it into something that is familiar, and then from there make like hypotheses and assertions, okay, and then from there try to prove your way and work your way through it, okay. But you can't start from nothing, okay. So that's why the process went the way it did. We had to draw in this line, okay, and then from there declare that that is a right angle there. And only at that point we were able to use Pythagorean theorem and sine, cosine, tangent. Okay.
Okay.
Anybody else have any other questions?
Mm-mm.
No? Okay. So I think this is great. I'm going to stop recording.